Alright, so this is our last one here. We're going to, given we have one of the zeros, we're going to factor this polynomial completely, and it says use a conjugate roots theorem if possible. Basically, we're just going to factor it and write it in its linear form, similar to the first few problems that we had. Okay, so this is what you need to understand. The fact that they're giving me x equals negative 3i as a 0. This I came from a square root. So you automatically know, or you should know, whenever we do square root, we get positive and negative. So the fact that they're telling me that this is a 0 also means x equals positive 3i is a 0. Okay, so these are two of my zeros. I can do I'll do synthetic division and find those two, and then we will be able to factor and find the other two zeros. I can actually graph it and see what those numbers might be, but I do want to show you how to do it with these. Actually, let's just do it by hand. So when you move these over, because you want to set these terms equal to 0, you will add this. So x plus 3i is one linear factor, and then when we subtract and move this over with x, we'll also have x minus 3i is a factor. So these are two of your linear factors. And then we need to get two more because we have a fourth degree. So whatever your degree is tells you the number of zeros that you will have at most. So I'm going to do synthetic with the negative 3i. That's the one that gave me first. Negative 3i. Okay. My coefficients would be 1. Move this mouse out of the way. Negative 2, negative 26, negative 18, and negative 315. Bring the first number straight down, 1. Okay, times a negative 3i will give me a negative 3i. Okay, the 2 and the 3i are not like terms. They don't have the same variable, this I. So I have to write them down separately. So I have a negative 2 minus 3i here in that position. And separate these. Alright, so now I do negative 3i times both of these numbers. Okay, so negative 3i times a negative 2 gives me a positive 6i. I'm writing it at the back because I know when I multiply negative 3i times negative 3i, I get a positive 9i squared. Okay, so this is what I get. I'm going to erase this when I'm just showing you. 9i squared. I squared, we have to recall that that's equal to negative 1. So all together, we get a negative 9. So that becomes negative 9. So we have a negative 9 plus 6i. We can combine the 26 and the 9. That will give us a negative 35. And then plus 6i. Now we're going to multiply the negative 3i and the 35 and the 6i. Okay, so doing so will give us negative 3i times 35 gives us positive 105i. And then the negative 3i times the positive 6i will give us a negative 18i squared. and the I squared. So this is negative 18 I squared. I squared is negative 1, so when you multiply by negative 1, this becomes positive 18. Okay, so we have negative and a positive 18, they will go to 0, and then I'll just bring down my positive 105I. Okay, and then when I do negative 3I times 105I, gives me a negative 315I squared, which the I squared will turn it positive, so we get a positive 315, and then that gives us 0. Okay, so that's what we should get at the end because it's a 0. Okay, a lot of work, but it's satisfying when you can do that. All right, so we're going to just continue right there. So remember, when you have square root, we get plus or minus answers. So the fact that you have an imaginary tells me that I have to have the opposite of that as well, plus and minus that. So I used the negative 3i. Now I'm going to use the positive 3i. So positive 3i. And I'm just going to pick right up where we left off using these factors. So I'm putting separations or partitions so I know that even though it's two numbers, it's that one term right there. Okay. So I'm going to bring this 1 straight down. So remember, this was x to the 4th. Now we're at x to the 3rd. And then I'll end up with x squared, and I should be able to factor that. Alright, so bring the 1 straight down. Again, we're going to multiply times 3i. Bring that up here. So 3i will combine with the negative 3i, and it will 0 out. And I will just bring down a negative 2. Alright, now I'm going to multiply 3i times negative 2. Gives me a negative 6i. And that will combine with the 6i term, which will 0 out, and I will bring down a negative 35. Alright, and now I'll multiply 3i times negative 35, which will give me a negative 105i. Combine these, and we get 0. Okay, so these two are zeros. Here are the two linear factors. Remember, they came from whatever the zeros are, you move it over, get the opposite sign, because we're going to need to list these in our answer. This is part of our answer. We got 2 more to find. We're going to find from here. So now this one is an x squared, and I'm going to see if this factor. So we have 1x squared minus 2x, and then minus 35. So we're looking for factors of 35 that subtract and give us 2. I think there's only the 7 times 5. Okay, so we will use those. So I'm going to do 2 sets of parentheses, and we have x, and we're going to put in the 7 and 5. The first sign tells me the bigger number, so 7 is bigger, it's negative. Second sign, being negative, tells me that these will be different. Negative means different. If this was positive, they would be the same. Same, this means different. D-I-F-F, this abbreviation. So if you already got the first sign and they're going to be different, this one has to be a positive. Okay. So here are the other 2 linear factors that we need. We don't have to set them equal to 0. I just need to find those numbers. Okay, so our answer in this box, written in linear factors, is going to be x plus 3i, and then butted right up against that in parentheses is x minus 3i, and then we got the 2 factors that we just found when we factored the last part. So x minus 7, I missed my x, I got a second set of parentheses in there. Okay, x minus 7, and then we need x plus 5. Okay, so this is what they mean when they say linear factors.